So today we're going to do number 33 of chapter 6 homework, and I'm going to explain to you how to hopefully fully solve this problem. So the problem we are given is that a 9 kilogram object starting from rest falls through a viscous medium and experiences a resistive force R equals negative BV, where V is the velocity of the object. The object reaches 1/2 of its terminal speed in 5.54 seconds, and it asks A determine the terminal speed. So we currently haven't learned how to solve for the velocity of an object, which is going into terminal velocity, and so I'm here to help out right now. So this is the object moving through the viscous liquid. It has a downward force of W, which is equal to mg, and then it has an upward resistive force of R, which is equal to bv. And so when we sum our forces together, we have forces equals mg minus bv, which equals ma. So the weight down minus the resistive force is equal to the mass times the acceleration of the object. So first we're going to do some manipulation of the equation. So we're going to divide everything by mass. So A equals the gravitational pull minus bv over m. Next we have acceleration equals negative bm times the quantity of v minus mb times g. So what I did here was to take out the negative bm so that velocity was by itself. Next I'm going to go and say that acceleration is the change in velocity over the change in time, which is equal to the same thing as last time. Now I'm going to split the functions up into two. So the change in velocity times 1 over velocity minus mg over b is equal to the change in time times negative b over m. So what this is doing is making it into a separable function, separable differentiable function, and so then we're going to integrate. So we do the integral of dv times 1 minus v over mg, v minus mg over b is equal to the integral of dt times negative b over m. So one thing we know is that ln x the derivative of ln x equals 1 over x, and so the antiderivative of 1 over v minus mg over b would be ln v minus mg over b, and since anything inside the log of the natural log function must be greater than 0, we are going to take that absolute value, and then on the other side of the equation we have it equal to negative b over m times t, which is fairly simple. So it's just the antiderivative of negative bm, and then we're going to add c. You might think that c would have to be another type of constant would have to be added on the left side of the equation, but this is not true because you would just subtract it and then it would be c, so we're only going to put it on one side. So next we're going to take everything to the e power, and then so that's going to leave us with the absolute value of v minus mg over b equals e to the negative bmt plus c. So what we're going to get here is next we're going to take away the absolute value, and so v minus mg over b equals plus minus, because of the absolute value, of e to the c times e to the negative bt over m, which is equivalent to e to the negative bm t plus c if you know the functions of powers, the rules for powers. And so now we're going to go into solving. There's always conditions for the function, and for that it's that at time equals 0 the velocity is also equal to 0, which was given. So we plug those into the equation I just solved for. So that would be 0 minus mg over b equals plus minus ec to the e to the negative b times 0 over m. So the exponents go to 0, and then the entire function, the entire e to the 0 goes towards 1. So we're left with negative mg over b equals plus minus c. Next we're going to plug in, oh that was much better, sorry. Next we're going to just plug that in right back into the equation. So v minus mg over b equals mg over b, which is equivalent to plus minus e to the c times e to the negative bt over m. Velocity is then equal to mg over b minus mg over b e to the negative bt over m. And then we're going to just factor out mg over b, and what we're left with is v equals mg over b times 1 minus e to the negative bt over m. And so first what we're going to do is find b. So what we know is that mg minus bv, and then here's terminal velocity. At terminal velocity, mg minus bv of t equals ma. And we know that once it hits terminal velocity, the velocity is constant, therefore acceleration is 0. So mg equals b times v terminal velocity, and then terminal velocity equals mg over b. So now we know that at t equals 5.54 seconds, the velocity is 1/2 of the terminal velocity. So v of t equals mg over b times 1 minus e to the negative bt over m. So we're just going to plug that in, and then what comes out is 0.5, so half of the terminal velocity, is equal to mg over b being the terminal velocity, therefore cancelling out, times 1 minus e to the negative bt over m. So what we're going to get is just 0.5 equals 1 minus e to the negative bt over m, and then we're just going to swing the 1 over to the other side, so it becomes 0.5 minus 1 equals negative e to the negative bt over m. So we're going to shift that over, so get rid of all the negative signs. That would, and then take the natural log of it. So the natural log of e to the negative bt over m equals the natural log of 0.5. Then negative bt over m equals the natural log of 0.5. You solve for b by multiplying m and then dividing by t. And so we do plug in the numbers. We know that it's 9 kilograms, negative 9 kilograms times the natural log of 0.5 divided by 5.54 seconds. And that gives us this value, 1.126 kilograms per second, which becomes 1.13 kilograms per second. And now we are going to go to A, because we're ready to start that finally. So let me zoom out as much as I can. Okay, so we're given that v of t equals mg over b times 1 minus e to the negative bt over m. So we know that t equals 5.54 seconds, v equals, and that at that time we are given that v equals half of the terminal velocity. That mass is 9 kilograms rather, and b equals 1.126 kilograms per second. Oh yes, sorry, I forgot to mention you have to put in the units, kilograms over seconds. So we do v of 5.54 seconds, then we plug in the numbers, and so we get half of vt, which is v of 5.54 seconds, is equal to 39.16 meters per second. We're going to just divide by 0.5, and what we get in the end is v, the terminal velocity is 78.3 meters per second. Okay, in B, what they ask you is at what time is the speed of the object 3/4 of the terminal speed. So we don't know the time. We know that the velocity at the very end is 0.75, which is 3/4, v times the terminal velocity. That terminal velocity is 78.32 meters per second, and that mass equals 9 kilograms, and that B equals 1.126 kilograms per second. So now what we do is Vt equals mg over b times 1 minus negative bt over m, which was the equation we solved for. So at the time that we are solving for, 0.75 of the terminal velocity equals the terminal velocity, because remember, mg over b equals the terminal velocity, is times 1 minus e, and then we plug in the numbers up there. So we get 0.75 equals 1 minus e to the t times negative 0.1251 1 over seconds, which is what we get when we multiply everything out in the exponent. We take the natural log after we subtract, so 1 minus 0.75, and put the e over on the other side would be, and then we take the natural log, so natural log of e to the t times negative 0.1251 1 over seconds equals the natural log of 0.25. We do t times negative 0.1251 1 per second equals ln 0.25. T would equal ln natural log of 0.25 seconds divided by negative 0.1251, and that comes out with 11.08 seconds, which goes up to 11.1 seconds. Okay, so finally we are at C. C is different due to the fact that we cannot use our kinematics equations, because that was assuming constant velocity, and of course velocity is not constant. Rather, acceleration was constant back then, and now we do not have a constant acceleration. It's changing due to the force against it. So what I'm going to do is say dx over dt, which is velocity, equals mg over b times 1 minus e to the negative bt over m. So basically the same thing. Now we're going to split the functions up into different regions. So we do the integral of the initial position to the final position of dx equals the integral of the time at 0 to the time t of mg over b times 1 minus e to the negative bt over m times dt. So we get x minus x naught equals, and I didn't do the entire thing yet, but it would be mg times t. So mg over b rather is a constant. It's all numbers that we would not be solving for anymore now that we are given it. And then so the function 1 minus e to the negative bt over m, where time is changing, would be the only thing that we would have to worry about actually taking the antiderivative of, which is t from 1. And then for e, it would be, we would just have to think what would become negative e to the negative bt over m. And we know that e to the x, the derivative of e to the x is e to the x, and therefore the derivative of e to some constant times the variable that is changing would be the variable times e to the same thing as it was before. So we would do plus m over b e to the negative bt over m, and then we would evaluate that from 0 to time t. And so I was just going to multiply it out, so it would become mg times mgt over b plus m squared g over b squared times e to the negative bt over m. So now we're going to plug in 0 and t. So initially we start out with mgt minus b over b minus mg times 0, which is the time we plugged in, over b, which would all go to 0. And then m squared g over b squared times e to the negative bt over m minus m squared g over b squared e to the negative b times 0, which would make the entire function of the entire exponent equal to 0, and therefore e to the 0 equals 1. So what we get is the change in position equals mgt plus b times m squared plus m squared g over b squared e to the negative bt over m times minus m squared g over b squared. And so we're going to just factor out the m squared g plus b over b squared, and it becomes the change in position equals mgt over b plus m squared g over b squared times e to the negative bt over m minus 1. And so now we're just going to have to plug in. So we have mass equals to 9 kilograms, time equal to 5.54, sorry, that should say seconds. B equals 1.126 kilograms per second. And then we have the change in position is, we're just going to plug in all the numbers here. And what you should come out with is 433.9 meters minus 313.0 meters. That would become 120.9 meters, and then therefore the change in displacement is 121 meters. Okay, thank you very much. I hope this helped.